Welcome back to the Psyche and Singularity series. I'm going over my book, Psyche and Singularity, Jungian Psychology and Holographic String Theory. In this video, it's the most complicated chapter of the book I'll be going over, and it's where I'm pushing my knowledge of math to the limit, but I'll be demonstrating the intense parallels between the evolution of imaginary numbers on the unit circle and then the Riemann sphere in the mathematical sphere. I'll be comparing that to Jung and Pauli's theory of the mandala image of the one, the archetype of the self, the Unus Mundus, the God archetype. So the whole book is based on Jung and Pauli's theory that every law of physics should be mirrored by and mirror a law of psychology, because mind and matter both come from the same archetypal source, which they call the Unus Mundus, which means one world. And it's equivalent to Plato's idea of the good. It's the source of everything. It's the container of everything. So if every law of physics is mirrored by a law of psychology, and if the laws of physics are presented mathematically, we should see some parallel between Jung's mandala image of the self theory and some mandala in the mathematical world. So that leads us to the unit circle, which describes the square roots of, well, the square root of -1. So that, and then that's transformed into the Riemann sphere. So all I know about the unit circle and the Riemann sphere, and that they were applied, they became the basis of general relativity and quantum mechanics, which were unified in string theory. All I focus on in the book is how closely the evolution of the number 1, our understanding of the number 1, which grew to include -1 and then finally the square roots of -1, it forms a perfect mandala, a two-dimensional mandala. When you transform the Cartesian grid, you've got the x-axis and the y-axis, and if you transform the vertical axis on the Cartesian grid, it becomes to include imaginary numbers, it becomes the imaginary number line. So for those people who don't know, imaginary numbers are the square roots of negative numbers, and they were first written down as an answer to an equation in 1545 by Jerome Cardan, a Renaissance Italian. So how can you have a square root of a negative number? So the square root of 4 is 2, because 2 times 2 is 4, but it's also -2, because -2 times -2 is also +4. So you can't have a square root of a negative number, because a positive times a positive equals a positive, and a negative times a negative equals a positive. So how do you have a square root of a negative number? Well, Cardan just wrote in the equation for the square root of -1, and this is, it's now known as I. It's denoted as I, the imaginary unit. And this now surpasses my understanding of mathematical physics, but it was the way they described the square root of -1 led to the ability to mathematically describe four-dimensional space-time and quantum mechanics. So Wolfgang Pauli was particularly impressed with the correlation between the mandala theory that he developed with Jung and the unit circle, as we're going to see. So let me just take some guidance here from the book, and I will first just explain. So one of my sources of information here was a book called Number, The Language of Science by Tobias Danzig, a University of Maryland professor, and his book was 1930. So Einstein thought well of the book, and so I used it as the source of the history of mathematics. And so he's the one who I learned that Jerome Cardan in 1545 was the first to dare to denote the meaningless by a symbol. the square root of -1. And even then, it was kind of dismissed, but Danzig says that it was written with the reservation that it was meaningless, sophisticated, impossible, fictitious, mystic, imaginary, yet there is a great deal in a name, even if it be but a nickname or a term of abuse. So the square root of -1, originally rejected and abused, finally became the cornerstone of 20th century physics. And so Danzig explains that in 1831, Carl Friedrich Gauss gave imaginary numbers a geometrical expression on the Cartesian grid. So I will just show you a picture here of the unit circle. So as you can see, the horizontal line is the regular number line of positive and negative real numbers, and then the vertical axis is positive and negative imaginary numbers. And imaginary numbers are the square roots of negative numbers. And here's how it works. So if you take 1, I'll just use this as a diagram, and you multiply it by the square root of -1 to the power of itself, so I. So 1 times I equals -I. 1 times I squared equals -1. Because I is the square root of -1, I times I equals -1. So 1 times I to the third equals -I, and then finally I to the fourth comes back around to I. So that is also very similar to what Jung calls the axiom of Maria. The alchemists in the medieval era, according to Jung, alchemy was a proto-form of psychology. They were seeing in the combination of chemical ingredients, that was how they were projecting archetypal combinations of the mind. And so the axiom of Maria says, out of the third comes the one as the fourth. So from the one comes the two, from the two comes the three, out of the third comes the one as the fourth. And you see that in the unit circle. I to the third equals -I, and then I to the fourth comes back as 1. So the axiom of Maria, according to Jung, was how the alchemists were imagining the individuation process. So individuation, as I've discussed in previous videos for Jung, is the psychological process of uniting your conscious ego with the unconscious mind, the collective unconscious archetypes, and society as a whole. So uniting all opposites into one whole person. That's individuation. And the axiom of Maria implies that it goes through 4 phases to become whole. Okay, if there's a psychological process of individuation that goes through 4 phases in such a way that from the third comes the one as the fourth, then does that have a mathematical parallel? It should, if mind and matter mirror each other, and if number is the common ground connecting mind and matter, which is a point Jung makes. It's also a point Plato makes. But at any rate, yes, the axiom of Maria seems to be mirrored by the unit circle. That's what the circle of imaginary numbers is. And it also fulfills Jung's theory about the mandala images. They emerge when the psyche is pulled by opposing demands, irreconcilable demands. So in the field of mathematics, there was the irreconcilable demands of real numbers and imaginary numbers. How do you fit the two together? These opposing types of numbers. Well, if Jung's theory that opposites are united in the archetype of wholeness through the union of opposites, the image of which is a mandala, then we should see some mandala emerge in the mathematical field to unite the opposing types of numbers, real and imaginary, and that's what we see in the unit circle, this perfect mandala. So not only is it a perfect circle, but it's divided into 4 segments, and that's another big part of mandala imagery, according to Jung. It's a combination of the square and the circle, and it usually involves 4 phases of development. And you see all of those elements in the unit circle on the complex plane. And Jung and Pauli both mention this parallel. It was extremely important, especially to Wolfgang Pauli. And I will read, actually I'll skip ahead a little bit from the order in the book. So here's what Pauli did in one of his active imagination sessions. So to communicate with the unconscious mind, Jung advises that you pay attention to your dreams. The symbolic imagery from your dreams is the language of the unconscious, the collective unconscious mind. Another way of arousing these images is to just let your imagination go while you're awake, active imagination. So during one of those kinds of sessions, Wolfgang Pauli, he imagined, he wrote about it, he titled it The Piano Lesson, and he imagined a Chinese lady who reminded him of his grandmother, and she was playing the piano. And at one point during the piano lesson, she pulled the ring off her finger, which Pauli said he hadn't noticed before. She let it float in the air before her, and she says this is the ring I, the ring of imaginary numbers. Then she said it makes the instinctive or impulsive, the intellectual or rational, the spiritual or supernatural, of which you spoke, into the unified or monadic whole that the numbers without the I cannot represent. So it unites the instinctive, the intellectual, and the spiritual. It unites the conscious and the unconscious. Without the I, numbers cannot represent the whole psyche, conscious and the unconscious. So then Pauli responds to her, the ring with the I is the unity beyond particle and wave, that's quantum mechanics, and at the same time, the operation that generates either of these. It is the atom, the indivisible, in Latin. So the imaginary unit and the unit circle, which is then expanded into what's known as the Riemann sphere, which I'll describe in a moment, are the foundations of general relativity and quantum mechanics. And they use these mathematical tools to describe, in quantum mechanics, the particle wave paradox. So the main thing that I focus on in the book is we're looking for parallels between the laws of physics and the laws of psychology. At the root of both, you have this unit circle. The one is the archetype of the self. It's known as the one, Unus Mundus, the God archetype, and the self. So the psychological manifestation of the one is our psyche. What's the mathematical reflection of the number one? Would be the unit circle. And that fourfold progression of the number one from 1 up to I, down the negative 1, down to I, to a negative I, back up to 1, that's the perfect mathematical mirror of the psychological individuation process. It was predicted there would be this parallel, and then you see a perfect match. And then when we see that unit circle expanded to the Riemann sphere, the parallels between the number 1, which includes the square root of its negative, and the shape of the cosmos and the psyche, they all start to merge together, which is what you would expect according to the theory of this mirror symmetry between mathematical physics and psychology. Okay, so going back just a little bit, the problem with, here I'll read this from Civilization in Transition, Jung is describing the way mandalas appear. He says, mandalas usually appear in situations of psychic confusion and perplexity. The archetype thereby constellated represents a pattern of order, which, like a psychological viewfinder, marked with a cross or circle divided into 4, is superimposed on the psychic chaos so that each content falls into place and the weltering confusion is held together by the protective circle. At the same time, they are yantras, instruments with whose help the order is brought into being. But the psychological viewfinder, like a rifle scope, he's saying this is how mandalas emerge. It's a circle, you've got a chaos of incommensurable demands on you. So to transform the chaos into order, your psyche produces images of mandalas, specifically a circle divided into four, like a viewfinder. And that's exactly what we saw. The chaos of the introduction of imaginary numbers forced the recreation of the Cartesian grid to include imaginary numbers. And again, it was the mandala divided by a viewfinder that did that. So it was a perfect match for the way mandalas, the way Jung said you would predict mandalas to appear. If you look in throughout history and you see pictures of mandalas, he'll point out they're usually circles divided into four. And so again, we see that. Okay, so mathematically, now this is where I'm just taking it from the experts. The problem with the complex number plane, which is what you get when you introduce imaginary numbers to the Cartesian grid, it's a complex of real numbers and imaginary numbers. So that's the complex number plane radiating out from the unit circle. The problem is you cannot divide, and I'll read here. There was, however, one major hole in Gauss's geometrical interpretation of imaginary numbers, the inability to divide complex numbers by zero, which causes one line of the representative triangle to stretch out to infinity, which has no representation on the complex plane. Okay, you can't divide complex numbers, which is a union of real and imaginary numbers, by zero, because the way you multiply complex numbers, it's represented by a triangle. You connect two lines on the complex plane. I'm not sure exactly how it works, but there's no way to represent infinity on the complex plane. So Gauss's student, Riemann, Georg Friedrich Riemann is his name. I'm trying to make sure that I didn't miss one of his many parts of his name. At any rate, on June 10th in 1854, he defended his dissertation to Gauss. Gauss was his PhD mentor, and he gave an explanation of how you can divide complex numbers by zero in his lecture titled "The Hypotheses Which Lie at the Foundation of Geometry." He took the complex number plane and rolled it into a sphere with the North Pole representing a point at infinity. So here's just in the book a picture of the Riemann sphere. So that I will read, according to Robert Osserman, the former chair of the Stanford Mathematics Department, which I make a point of that because Leonard Susskind teaches at Stanford, and the former chair of the mathematics department there, Robert Osserman, had a much more of a soft heart towards mystical interpretations of mathematics. And he said about Riemann's 1854 PhD defense that it is, now we now see clearly in retrospect as marking the birth of modern cosmology. So it was the introduction of the Riemann sphere that where the mathematical tools required for 20th century physics were born. Michio Kaku says the same thing. He said on June 10, 1854, a new geometry was born in his book Hyperspace. So it was from 1912, and this is, I'm getting from Michio Kaku, from 1912 to 1915, Einstein was looking for a way to reconcile the absolute speed of light that he underscored in his special theory of relativity with Newton's theory of gravity, which implies that gravity travels infinitely fast. If the sun evaporated according to Newton's theory, the Earth and all the other planets would instantly careen out of their orbits. That would imply an instantaneous gravitational connection between the two, which would violate the speed limit of light. So how can I describe gravity, says Einstein, in a way that makes it obey the absolute speed of light? I don't have the mathematical tools I need. And he was going crazy. He appealed to his friend, Marcel Grossman, for help. And this is a quote: "Grossman, you must help me or else I'll go crazy. So then Grossman, according to Michio Kaku, accidentally stumbled on the work of Riemann, which is the 1854 lecture, and then Einstein found a, quote, line for line, unquote, correlation with Riemann's mathematical mandala. The number one, in Kaku's words, the physical reinterpretation of Riemann's famous 1854 lecture is now called general relativity, and Einstein's field equations rank among the most profound ideas in scientific history. So the Riemann sphere was the perfect match for Einstein's idea that gravity is the curvature of the three-dimensional surface of the four-dimensional fabric of space-time. So again, how do you unite the opposites of space and time, which you needed to do to make gravity obey the speed of light? Well, you've got these two cosmic opposites, space and time. It doesn't get more cosmic than that. These two archetypal opposites. The only way they can be unified, according to Jung's theory, or at least you would expect, the union of opposites occurs through the unifying power of the archetype of the one, which manifests as a mandala. And so again, you see the Riemann sphere, a perfect mandala, with furthermore that North Pole representing a point at infinity. So that Riemann sphere is very similar to the claim that God is a sphere whose center is everywhere and circumference nowhere. So Jung points out that idea of God, the sphere whose center is everywhere and circumference nowhere. He traces it back to Plato and St. Augustine, and it was repeated by people throughout Western history, including Blaise Pascal, the great mathematician and theologian. And so I do want to read, and then they also compare that image of God as the sphere whose center is everywhere and circumference nowhere to Dante's cosmology, which pictures the universe as a sphere, with the outermost sphere being the house of God, and God specifically being described as a brilliant point of light that somehow encompasses the outermost sphere. That the parallel between that was also pointed out by the Robert Osterman, the chair of the mathematics department formerly at Stanford. He points out that, he says, the Big Bang occupies the position where Dante placed a point of light radiating with great intensity. That's the Empyrean. So so I'm just going to focus a little bit here on this idea of God as the omnicentric point. So Carl Jung points it out, but I'm going to read to sort of tame the many quotations that I use in the book. I'll just point here to Joseph Campbell in The Masks of God. He writes, the principle of relativity had been defined already in mythopoetic, moral, and metaphysical terms by the medieval claim that God is an intelligible sphere whose center is everywhere and circumference nowhere. So Joseph Campbell is pointing out this parallel between relativity theory and that image of God, which can really be boiled down to the parallel between that image of God and the Riemann sphere. So now I'll read what Blaise Pascal writes in his book Pensées, or Thoughts. He said, nature is an infinite sphere whose center is everywhere and circumference nowhere. In short, it is the greatest perceptible mark of God's omnipotence that our imagination should lose itself in that thought. So the greatest perceptible mark of God's omnipotence, that's saying a lot. What's the greatest perceptible mark of God's omnipotence? Oh, the fact that nature is an infinite sphere whose center is everywhere and circumference nowhere. Coming from Pascal, that's quite a claim. And then, so that is mirrored by Carl Jung himself in Memories, Dreams, Reflections. He said, I knew that in finding the mandala as an expression of the self, I had attained what was for me the ultimate. Perhaps someone else knows more, but not I. So that agrees with Pascal. The greatest perceptible mark of God's omnipotence is this mandala image of the self, or of God, with whom Pascal was openly and voluntarily obsessed. The idea of God, for him, was the utmost quest for the human being, and he says the greatest mark of God's infinite power is this mandala image of this omnicentric sphere, which would make sense if the psyche is the singularity. If the gravitational singularity, which includes the cosmic horizon, is the self, then everything starts to fall into place. It's not that Pascal and Jung are exaggerating. That would be the greatest mark of God's power, because it encompasses the entire universe from the infinitely powerful central point, which is present at each point of the sphere. But how is it that God's this center point that's everywhere and circumference is nowhere? Well, if we look at this from Susskind's holographic string theory, his concept of cosmic complementarity can help explain this greatest perceptible mark of God's omnipotence, or of the omnipotence of the archetype of the one. So, according to Susskind, from our perspective on Earth, if we had a telescope that could see out to the horizon of the cosmos, and if we had a thermometer on a spool that could be unspooled that far, 14 billion, 15 billion light years away, we would see all of the information radiating out there, smeared out on an infinitely hot horizon, and then radiating back with the cosmic microwave background radiation. But if we were traveling freely out through space towards that horizon, which from our perspective looks infinitely hot, as we approached it, we wouldn't notice anything unusual. We'd flow freely past the horizon as if nothing was there. So he calls that cosmic complementarity. From one perspective, the horizon's infinitely hot. It conserves all of the information of the universe and radiates it back in. From another perspective, there is no cosmic horizon, because as you approach it, it recedes. So that gives some explanation for this idea of God as the sphere whose center is the infinite sphere, whose center is everywhere and circumference nowhere. No matter where you are in the universe, it appears that you're the center of an expanding universe. All the galaxies will appear to be expanding away from wherever you are at an exponentially accelerating rate. We cannot help but see ourselves as the center of the universe. So the universe, wherever you go to observe the universe, you're always there in the center. That's one way to see this idea of God as the omnicentric point. Another one comes from Blaise Pascal himself. He said in aphorism 420 in Pensees, he says, "Oh, you think it's impossible to think of God as omnipresent and yet indivisible? Because if something is spread out in space, you could divide it. At least you could imagine dividing it." He says, "Very well, I'll show you something omnipresent and indivisible, a point traveling everywhere infinitely fast. It remains a point, but it's everywhere simultaneously, because infinite speed is instantaneous. So it's here and here and here and everywhere else throughout infinity simultaneously, although you can't divide a point." So he's saying, by that one example, you should know that God can be everywhere. Well, if we equate the God archetype with the gravitational singularity, that just gives one more insight into how this ancient idea of God as the sphere whose center is everywhere and circumference is nowhere, it starts to make more sense. So there are some more details I talk about in the book regarding that, but I'm going to leave that there for now. But to recap, before I get into Susskind's reconciling general relativity and quantum mechanics, it's important to know that general relativity is founded on the Riemann sphere. That mathematical sphere, which represents the complex plane rolled up to a point at the north pole of that sphere is infinity. That is the mathematical expression of the physical principles of general relativity. Now that goes beyond my capacity to comprehend. I'm just looking for parallels to verify Jung and Pauli's mandala theory. If the mandala images that emerge in the psyche are rooted in the self, we should find some parallels in mathematical physics, and the Riemann sphere which is a expanded unit circle in the complex number plane, is the perfect match. Quantum mechanics also uses the Riemann sphere and the concept of imaginary units. I don't know exactly how they do it, but Pauli was convinced it's absolutely necessary to use imaginary units or imaginary numbers to understand the wave and the particle nature of the quantum world. So next, and I complete the mandala chapter by talking about how Susskind himself, by reconciling Susskind and Gerard de Hooft, his partner, by reconciling general relativity and quantum mechanics within their understanding of a black hole, again, perfectly conforms to the mandala theory. The compensatory mandala theory is the image of the archetype of wholeness through the union of opposites. So in his book, The Black Hole War, I am going to actually pick up that book. He talks about in January of 1981, he was invited to a physics conference hosted by Werner Erhard, whose original name was Jack Rosenberg. So he was apparently a kind of a self-help guru in the San Francisco area, and he loved to host high-level physics conferences. So it was at one of those physics conferences in the attic of Werner Erhard's mansion in San Francisco that Hawking first met Gerard de Hooft and Stephen Hawking, and it was in that lecture series at the last day that Hawking presented his theory that black holes destroy information. That information falls into black holes, and then because of Hawking radiation emerging from the quantum vacuum, black holes very slowly but surely evaporate, and once they completely evaporate, all the information that fell inside of them is erased from the universe. Susskind said he realized that, if it was true, would destroy the most fundamental principle of physics, which he says is the principle of the conservation of information. It had to be wrong, and yet Hawking's mathematical ideas seemed to be correct. So he remembers seeing 't Hooft after the lecture staring at the board where Hawking had his assistant write a diagram of what he was talking about with a huge frown on his face, whereas Hawking had his devilish grin on his face. And this was before he used the computer to talk. So he would talk almost incoherently, and then one of his assistants would translate. So that was the beginning of the black hole war. And if you compare the way Jung says that this conflict of opposites that causes mandala images to emerge, what kind of a psychological situation would cause that? If you compare Jung's description of that scenario to Susskind's description of the origins of the black hole war, you'll see it's a perfect match. So I will read a little bit from my book, but I'm quoting from Memories, Dreams, Reflections. So he's talking about God as the complexio oppositorum, the union of opposites. And he says that the complexio oppositorum of the God image thus enters into man, and not as unity but as conflict, the dark half of the image coming into opposition with the accepted view that God is light. And then he goes on to say, the clash, which is at first of a purely personal nature, is soon followed by the insight that the subjective conflict is only a single instance of the universal conflict of opposites. Our psyche is set up in accord with the structure of the universe, and what happens in the macrocosm likewise happens in the infinitesimal and most subjective reaches of the psyche. For that reason, the God image is always a projection of the inner experience of a powerful vis-a-vis, which means face-to-face. So, analyzing that, first he says, the complexio oppositorum of the God image thus enters into man not as a unity but as conflict, and it's the idea of God as the dark half coming into opposition with God as light. So the dark half of the God image would be Stephen Hawking's idea that black holes swallow information. That's darkness. They leave no light escapes black holes. Therefore, no information escapes them. That was destroying the whole field of physics, Susskind and 't Hooft realized. If Hawking's right, then physics must be wrong. And yet, Stephen Hawking seems to be unconcerned with the fact that his own theory undermines the validity of physics itself. So that the image that God is light is the idea that information is conserved. So you see this is the archetypal principle of this universal opposition would have triggered, if Jung is correct, some kind of an instinctive response from those who could understand it. And Susskind said it was only him and 't Hooft who understood the importance of this challenge that Hawking was presenting. So then, going back and so Jung says at first, the clash is of a purely personal nature. But then you realize that it's an instance of a universal conflict of opposites. So, the clash, now I'll read from Susskind's book, The Black Hole War, and even uses that word, the clash. So the very word that Jung said, the clash of opposites, inspires these mandala resolution to the issue. So here's how Susskind describes this traumatic experience of seeing the dark image of Hawking's black hole theory. So he says, in the days and weeks after the meeting in Werner Erhard's attic, it began to dawn on me that Stephen Hawking had put his finger on a clash of principles that rivaled the great paradoxes of the past. Something was seriously awry with our most basic concepts of space and time. It was obvious, Hawking had said it himself, that the equivalence principle in quantum mechanics were on a collision course. The equivalence principle refers to general relativity. Acceleration is equivalent to gravity. So general relativity and quantum mechanics were on a collision course. The paradox could bring down the whole structure, or reconciling the two could bring deep new insight into both. So he goes on to say that he found it intellectually intolerable to leave these two theories of physics unreconciled, and that he was obsessed with getting Stephen Hawking to see how they should be reconciled. And finally he said, and I'm quoting from the same section in the book, he says, the key was not to abandon quantum mechanics, but to reconcile it with the theory of black holes. So, again, this unbearable compulsion to reconcile opposing principles, specifically the idea that information is destroyed, is exactly what Jung said usually happens. And I think that I will read a little bit from a documentary, Who's Afraid of a Big Black Hole, one of my favorite documentaries on black holes. It's a BBC Horizon series. So this idea of reconciling opposites within the mandala of a black hole, you would expect that in the field of physics. So if the psychological symptoms of society mirror the psychological symptoms of the individuals in it, and that was one of Jung's ideas, then if we see an academic field pulled by opposing demands, we should see members of that field coming up with mandala images to help reconcile the opposites. And in the field of mathematics, that's exactly what we see time and again, from the unit circle, which unifies real and imaginary numbers, to the Riemann sphere, which allows you to divide complex numbers by zero, to black holes in holographic string theory, which unites relativity theory with quantum mechanics, at least mathematically. It hasn't been empirically verified, but the math works. And so the tension of opposites in the field of physics, I think, is very palpably described in this episode of Horizon, Who's Afraid of a Big Black Hole. So the narrator, Samuel West, he says, the failure of these two great theories to understand black holes means they are at best an approximation to the laws governing the universe. So you have to use general relativity and quantum mechanics to describe black holes, because singularities are infinitely heavy and therefore require general relativity to describe, and they're also infinitely small, so that's quantum mechanics. And yet those two languages of physics don't work together, so there's a crisis. So Andrew Strominger, a Harvard University physicist, he says the equations no longer make any sense and nobody knows exactly what we're supposed to do about that. Michio Kaku from the City College of New York, he says, well, it's awful. It means that physics is having a nervous breakdown. It means the collapse of physics as we know it. You know, something is fundamentally wrong. Nature is smarter than we are. So Andrew Strominger says black holes are the key to taking the next step. They're the doorway to our next step in understanding the basic laws of the universe around us. So the key to taking the next step is black holes, and I'm saying the key to a genuinely unified field theory is understanding the identity of the self or the psyche with the singularity. We each are a black hole. The cosmic horizon of the cosmos is the collective unconscious mind. The central point, which each of us perceives ourselves to be, is the ego, the field of light centered on the ego. That's how Carl Jung describes it. And there's this complementary relationship between the two. So we perceive ourselves in the center of a universe, a vast universe, our little tiny ego, but at the same time we're one with the collective unconscious cosmic horizon where the past, the present, and the future are superimposed at each point, and that projects the holographic illusion of our everyday world that our egos are living in. So you would expect, we've seen this throughout the history of physics and math, that the union of opposites is always achieved through some mandala ordering principle. So the final union of opposites would be the union of physics in general. So general relativity and quantum mechanics are unified in string theory, at least mathematically. Now you need to unify physics or string theory with psychology. So matter, the science of matter with the science of mind, and we should expect this to occur within a mandala ordering principle, and I'm saying it's the same one that Susskind used to reconcile general relativity and quantum mechanics. The holographic interpretation of the universe as an inside-out black hole is also the model of the psyche, especially when you incorporate Carl Jung's mandala theory and his theory, his near-death experience, where he experienced blissfully the past, the present, and the future of the whole cosmos. And he felt himself objectively interwoven with the universe itself. So I'm going to end this episode of Psyche and Singularity. The next one we'll talk about synchronicity. So meaningful coincidences make more sense if our psyches and space-time are merged at the horizon. But this union of physics and psychology in the inside-out black hole model of the universe presented by Susskind, I think the synthesis of Suskind's black hole universe and Jung's transpersonal psychology, including his near-death experience, if you synthesize those two, then you have a real unified field theory. The holy grail of unification, which physicists are looking for and so are psychologists. And I'll conclude with this quote from Pauli, who was looking forward to this union of psychology and physics. He says, I don't know whether and when this conjunctio will be realized, but I have no doubt that this would be the most beautiful destiny that could befall psychology and physics. So I think if we look at the Riemann sphere that is the model for the cosmos, if we can see it also as a model for the psyche, specifically by synthesizing Jung's psychology and Suskind's string theory, that beautiful conjunctio, I think, would make Jung and Pauli happy. And it would be nice to see Susskind jump on board. And at any rate, whether he does or not, in the next video, we will be talking about Suskind's string theory and Jung's synchronicity theory.